Thank you for volunteering to the Lower Great Miami River Water Quality Lab. I'm Sarah Meadows, Public Involvement Coordinator with the Hamilton County Soil and Water Conservation District, coming to you from the Great Miami River. We work closely with Rivers Unlimited to get this lab certified as Level 2 through the Credible Data Program. This means our data from the lab can be used at the state level by Ohio EPA, the county level by the Soil and Water Conservation District, by local nonprofits such as Rivers Unlimited, and others. This data can be used for regulatory purposes to identify red flags that help prioritize projects and other watershed planning purposes. For this reason, it's important that you follow the procedures outlined in this video. For example, every 10th sample will be a duplicate to ensure there are no errors along the way. If this is confusing, don't worry. There will be at least 2 lab managers on site during every sampling day. Mike Miller is the program manager, Lisa Lee is the lab manager, and Bernie Moeller is the quality control officer. Thanks for watching. Enjoy your video.
Hi, welcome to the nitrates tutorial. Today I'm going to show you how we in our lab test for nitrates in our water samples. So nitrate is a nutrient. It's actually an ion in the water that could indicate the presence of fertilizer runoff or wastewater runoff into our surface waters. We care about this because if there's too much nitrates in the water, nitrate along with phosphorus is an important building block for DNA, for algae and other organisms, and of course if we see an overgrowth or if we see an overabundance of nitrate, we can see an overgrowth of algae, which can impact our surface waters. Now let's take a closer look at how you will pour your samples and what that will look like when you come in for the day. So when you come in for the day, there will be a couple things ready for you to run your nitrates test. The first, you'll find tubes that will be labeled for the nitrate test. We'll show those in a second. We have a vortex machine, which will help you to spin the samples as you're reacting. A photometer, which is where we will measure the samples once they've been reacted. And then finally, your results will be entered into the computer, into our nitrates spreadsheet. So when you come in, your tubes for your nitrates analysis will be ready. They will be labeled. So we use a specific kind of tube for nitrates. It's a conical tube, and it is dedicated to nitrate testing. We do not mix these up with the other tests. There will be 4 kinds of labels that you will see on your tubes. The first are tubes that are labeled with a number and then an N. That's a standard. That's a reagent. And we'll talk about where we run those in the process. The second kind of tube you will see is an empty tube with a cap that has a number on it. That's your sample tube. And it's empty because we will be filling that with the sample. All right, next, along with your samples, you'll see another empty tube. It'll have a number and then a D. So this one says 1D. That means a duplicate sample for sample number 1. And then the last kind of label you will see, this one won't be empty. It'll have a couple milliliters of standard in it, and it will say a number and then a star. That means 1 spike. So what this means is that before you've come in for the day, the tube has been given a spike of a reagent, of a known concentration of nitrate. And then what you will do is add sample number 1 to that reagent. We'll show you what that looks like. All right, so again, when you come in for the day, your standards tube, labeled with the N, will already be filled for you. Your laboratory manager will have filled the reagents in those tubes. The first thing you're going to do is you're going to fill your sample tubes. And how we do that is we find our samples that came in from the field. Again, these will all be labeled for you. So here's an example. This is a field sample labeled number 1. All right, that's my sample number 1. So what I'm going to do is I'm going to take my empty tube labeled number 1. I'll take off the cap. Very important step. I'll take my field sample, I'll invert it a couple times. This is important because some of our nutrients are bound to sediment that is suspended in the sample. It's important that we get that suspended. We don't shake, we just invert. So I've inverted. I'll open my sample. And I'm going to pour to the 25 milliliter mark. And usually I'll hold this up to about eye level so that I can see that level. All right, so I've poured into the tube labeled 1. For sample number 1, remember I have a duplicate and a spike. So I'm going to do this again for my tube labeled 1D. Same thing, pour to the mark 25. Cap it. All right, remember we have one last tube for number 1, our 1 spike. And remember, we had a couple milliliters of reagent already in here. What we will do is the same. We fill it to the mark 25. We don't add 25 milliliters. We fill it to the level at 25. All right, so I finished sample number 1. Usually I will fill a couple at a time. Maybe I'll fill sample number 2 and 3, and then I'll move on to the reaction stage. So for this method, we're running a Hach Chemical Company method specific for nitrate measurements in water samples. When you come in for the day, you'll find a pouch for this reagent called Nitraver 5. It's important that you make sure that you have the right pouch at your station. Otherwise, your reactions won't work. Inside the pouch, you'll have many of these small pouches that contain the reagent. They say HR nitrate. And so it's good to check those things when you start running your reactions. So what we will usually do is we'll take a couple of these small pouches at the same time. So here I have 3. And I'll hold them at the top and I'll brush them or flick them. Sometimes we need to get the reagent down into the bottom of the pouch. So just a couple seconds. And then we will cut these open at the tear mark. So inside these pouches there's a powder reagent. And what we'll do is we'll pinch this open, makes it easier to pour. All right, and then I'll take my sample from the last step. Take my reagent and pour it in. And I want to try to get as much of that powder as I can get in here, so sometimes you might flick the pouch a little bit. Once you've got everything in there, replace the cap and set aside, and you'll fill up to 4 samples at a time. All right, so you filled your last tube. We'll replace the cap. We'll take 4 tubes at a time. They all have reagent in them. We'll place them on our vortex machine, hold them together, and then press down. This will get kind of loud. What it's going to do is it's going to shake the samples up. It's going to create a vortex in all of the tubes. We'll do that for 1 minute, so you'll want to set a timer once you start this vortex. All right, so it's been a minute. I've been spinning my samples. I'm going to return them to this tray and let them sit for 5 minutes. So for 5 minutes, the reaction will continue. What else will be happening is your reagent and your turbidity will be falling to the bottom of the tube. We'll show you what that looks like. All right, so after 5 minutes, we're going to read our samples. So when you come in for the day, your instrument will be set up for you. It'll be set up to run the multi-wavelength program for nitrates measurement. The reason we do that is we're performing two absorbance measurements at 750 nanometers and 500 nanometers. We do that to compensate for the turbidity in the sample. We're not filtering samples in this method, so there will be turbidity in your field sample. At this point, when we measure at 750 nanometers, we're measuring absorbance due to turbidity. At 500 nanometers, we're measuring the absorbance due to the color that was created in the sample from the reagent. So what we need to do then is subtract the measurement due to turbidity from the measurement for the color so that we ultimately arrive at a measurement that is attributed only to the nitrate concentration in the sample. This method will be set up for you. If it is not, or if at any point during the day you lose the method, find a laboratory manager and they'll help you set it up. All right, so while my samples are reacting, the first thing I'm going to do is I'm going to come to my instrument. If this is the first time of the day that I'm coming to the instrument, I need to perform a zero. So that's like a calibration for the instrument. It tells the instrument what a zero concentration of nitrate looks like. So what you will find when you come in next to your instrument, you will find these glass cuvettes. Something interesting that you will note about them is that they have numbers on the top. 628, that's what this one says. And I have another that says 628. What this means is that these two cuvettes are optically matched. So when I have two that have the same number, I can use those throughout the process together. If we have two different numbers, it means there could be some slight variations in the cuvettes. It could cause some slight variations in readings, which may impact our calibration and our QA/QC. So whenever you can, use those two matched cuvettes. So for my zero in one of these cuvettes, labeled 628, I have DI water. And I'm going to use this DI to tell the instrument what a zero concentration looks like. All right, so I will open the instrument. I will remove the light shield, place it in the direction of the optical path, close, and then press 0. All right, and so the instrument says 0 absorbance units, and what that means is it's read at the absorbance point and calibrated that to be 0. All right, so I've zeroed my instrument. I've waited my 5 minutes. It's time to read some samples. The first thing I will do at the start of my sample set is run my standards. Remember those tubes that were labeled with N's? Those go first. You will also measure those halfway and at the end of your sampling for the day. The first thing I will do is I will take my 0N tube. Remember, it had 25 mils. It's reactive. The reagent is at the bottom. All right? Now this is important. I have 25 milliliters in here. But my cuvette is only 10 milliliters. We do this on purpose. What I'm going to do is decant from the top. So I will pour up to about 10 milliliters, making sure to not pour out the reagent in the bottom. We don't need that. It doesn't have anything that we need to read, and in fact, the reagent and the turbidity can interfere with the measurement. So I filled my cuvette up to the 10 milliliter mark, and I'm going to read it in a very similar way as the 0 that I performed. I'll open the instrument. The optical path is going from your right to left. All right, and we keep that in mind. What we usually do is we'll look for that 10 milliliter mark and we'll place it in that direction. That way you're placing the cuvette in the machine the same direction every time. I'll close, and I'm going to press the read button this time. Last time we pressed 0, now we press read. So the instrument will take a couple seconds to read. And I've gotten some results. I've gotten 2 measurements at the 2 wavelengths, and then we'll show you how you will put those into the spreadsheet. So you've gotten your sample measurement. It's time to measure your next sample. So what I'm going to do is remove my cuvette. I'm going to dump my waste into the waste bucket. I'm going to take some DI water, so it's important that we're not cross-contaminating samples. So what I will do is I will rinse the inside of the cuvette, dump into my waste bucket. We'll do that 2 times. and dump. If in the process of rinsing, I've gotten some water on the outside of the cuvette, take a Kim wipe. Not a paper towel, so Kim wipes are lint-free. They won't leave any debris on the optical windows, so I'll wipe the windows. And notice throughout this process, I'm not touching the windows of the cuvette. I'm holding it by the top. This just minimizes error due to anything you might have on your glove. All right, so I'm ready for my next sample. I'll take my next tube. Remember, this is my one duplicate now. Sample number 1 duplicate. I'll do the same thing as before. Fill it up to the 10 milliliter mark. Place it in the instrument, close the window, and press read. And we'll input that into the spreadsheet as well in the next step. So you're ready to measure your samples. We've created a spreadsheet for you to enter the data. It's straightforward. And we'll show you where you can enter your data at different points. Remember, the first thing we did is we measured standards. Okay, there's a location in the spreadsheet for you to record the measurements that you got for your standards. You will record 2 things. Remember, we measured at 750 nanometers and 500 nanometers, and you got 2 results on the screen. We enter both of those in the spreadsheet. So what I will do is I will go to the spreadsheet in the standards section, and there is a row that says nitrate standard 0.5 milligrams per liter. And I know that that's what I have on the top of my tube, so I will enter the 750 and 500 nanometer results for that sample. I'll do that for all of my reagents, and then I'll enter the results for my sample as well. The samples are also in the same spreadsheet. If we scroll over, we see that the rows are labeled by number that corresponds to the sample number. All right, so I've got sample number 1. I field sample number 1. I'll enter my 2 results for that sample. Just next to that, remember we had a sample number 1 duplicate. I'll enter those results as well. And then lastly, next to that, I have a spike reading for sample number 1. I'll enter my 2 results for that as well. Once I've completed all those sample entries for sample number 1, I will now go down to sample number 2, and then you'll do that throughout the day. Remember that periodically throughout the day, you will measure and enter results for standards again, and those will always be on the right side of the spreadsheet as you move down. All right, so you've run all of your samples for the day. You've entered all of the results into the spreadsheet. Click Save and alert a laboratory manager that you finished your measurements for the day. And thanks for your help.
Hi again. Hopefully by now you're getting excited for the sampling season to start. Remember, we sample on second Saturdays from March through November. Samples collected should be turned into the lab no later than 11 a.m. Volunteers for processing should arrive around 10. If for some reason you can't come in or collect your samples, please contact Lisa Link and we'll find a substitute for you. Thanks again, and we look forward to a great sampling season.